Example, evaluate the iterated integrals. The inner integral from 1 to 2 are the limits of y, and the outer 0 to 3 are the limits of x. So first we integrate the innermost integral. So I have taken it out from 1 to 2 x square y dy. We will integrate this with respect to y and we'll get x square y square over 2. Now put y is equals to 2 minus put y is equals to 1. Simplify these two, we will get 3 over 2 x square. So now we have the solution of the inner integral. So we will replace 1 over 2 x square y with 3 over 2 x square, and the outer integral 0 to 3 is as it is, and we have to integrate it with respect to x. So after integration I will get x cube over 2, and the limits of x are from 0 to 3. Replace x with 3 and we'll get 27 over 2 as our final answer. Integrate from 1 to 2, integrate from 0 to 3, x square y dx dy. 0 to 3 are the limits of x, 1 to 2 are the limits of y. So first we integrate the inner integral. Integrate from 1 to 2, bracket, integrate from 0 to 3, x square y dx, integrate it with respect to x dy. After integration, we'll get x cube over 3y, limits from 0 to 3. Solve it, we'll get integrate from 1 to 2, 9y dy. Now integrate it with respect to y, we'll get 9y square over 2. Solve it and we'll get 27 over 2 as our final answer. Integrate from 1 to 5, integrate from 0 to x, 8x minus 2y dy dx. 0 to x are the limits of y and 1 to 5 are the limits of x. First we integrate the inner integral. So integrate from 1 to x bracket, integration of 8x minus 2y with respect to y will get 8xy minus y square. Limits 0 to x. Now replace y with x, we'll get 8x into x minus x square minus the lower limit 8x 0 plus 0 square. Simplify it, we'll get integrate from 1 to 5 7x square dx. Now integrate this with respect to x, we'll get 7 over 3 x cube from 1 to 5. So replace x with 5, we'll get 125 minus replace x with 1, we'll get 1. Simplify it, we'll get 868 over 3. Evaluate integrate xy dx dy over the positive quadrant of the circle x square plus y square is equals to a square. First we have to find the limits of x and y. So we are given a circle whose radius is a. So it means that the limits of x are from 0 to a and the limits of y are from 0 to a as well. Now integrate the inner integral, we'll get x square y over 2 from 0 to a. Put here a, will get a square y over 2 dy. A square over 2 is a constant, so we keep it outside. Now integrate with respect to y, we'll get y square over 2 from 0 to a. Replace y with a, will get a square over 2. Simplify it and we'll get a4 over 4. Find the area bounded by y square is equal to x and x square is equal to y. So for limits of x, we assume y square is equal to x is first equation, y is equal to x square is second. So we will solve these equations. We put y is equal to x square in first, we'll get x square minus x is equal to 0. Simplify it, x power 4 minus x is equal to 0. Take x as common, x into x cube minus 1 is equal to 0. We'll have x is equal to 0 and x cube minus 1 is equal to 0. Take cube root of it, simplify it, we'll get x is equal to 1. So the limits of x are from 0 to 1. Now for limits of y, we have y square is equal to x. Take the root of both sides, we'll get y is equal to root of x and y is equal to x square. So integrate from 0 to 1 for x, integrate from x square to root x for y, dy dx. Integrate this with respect to y, we'll get y x square to root x. Put the limits. Now integrate with respect to x, we'll get x power 3 over 2 over 3 over 2 minus x cube over 3, and the limits are from 0 to 1. Replace x with 1. We'll get 2 over 3 minus 1 over 3, and we'll get 1 over 3 square units as our final answer. Evaluate double integral where D is a region bounded by the parabolas y is equal to 2x square and y is equal to 1 plus x square. So for limits of x, 2x square is equal to 1 plus x square, we will solve these two equations. 2x square minus x square will get x square is equal to 1. Taking root of both sides will get x is equal to plus and minus 1. For the limits of y, we have 2x square to 1 plus x square. So now we will integrate the inner integral. We'll get xy plus y square, 2x square to 1 plus x square. Put here the limits, we'll get this expression. Simplify it, we'll get minus 3x power 4 minus x cube plus 2x square plus x plus 1. Now integrate with respect to x. We'll get this expression. Later on, put the limits from minus 1 to 1 and simplify it, we'll get 32 over 15. Find the volume of the solid that lies under the paraboloid z is equal to x square plus y square and above the region D in the xy plane, bounded by the line y is equal to 2x and the parabola y is equal to x square. For limits of x, y is equal to 2x is first, y is equal to x square is second. So we'll solve these two equations by replacing y is equal to x square in first. We'll get x square is equal to 2x. Shift 2x to the left side, we'll get x square minus 2x is equal to 0. Solve it and we'll get the limits of x from 0 to 2. So the volume will be integrate from 0 to 2, integrate from x square to 2x, x square plus y square dy dx. So integrate x square plus y square with respect to y. We'll get x square y plus y cube over 3. Now put the limits. We'll get this expression. Simplify it. We'll get minus x power 6 over 3 minus x power 4 plus 14x cube over 3. Now integrate with respect to x. Simplify it. We'll get 216 over 35. Find the volume of the solid S that is bounded by the elliptic paraboloid x square plus 2y square plus z is equal to 16. The planes x is equal to 2 and y is equal to 2 and the three coordinate planes. Z is equal to 16 minus x square minus 2y square from here. Volume is equal to integrate from 0 to 2, integrate from 0 to 2, 16 minus x square minus 2y square dx dy. So first we integrate the inner integral, we'll get 16x minus 1 over 3 x cube minus 2y square x. Simplify it, we'll get 88 over 3 minus 4y square. Now integrate with respect to y. We'll get 88 over 3y minus 4 over 3y cube. Solve it, we'll get 48 as our final answer. Recommended reference book or textbook for this course is Calculus Metric Version 8th edition by James Stewart. This is the end of the lesson. Thank you.